second order effects technology. Just listen to a conversation with Chris Dixon and David George at 816Z. And shout out to 816Z's podcast, always useful to hear their views on things. They talked about second order effects of technology, and I find that interesting because when we invest, we often get actually caught with these types of first, second, third order type effects, and whether we know it or not, maybe that's not even that important, but I feel like it is useful to classify it when you see it. So one of the second order effects that they were talking about in the conversation was, let's say, the second order effect of social media and like Bitcoin, for example, or Trump populism. Like Trump populism would not have been possible without social media. I would argue even Tesla would not have been possible without social media, because the gatekeepers of opinion, like newspapers and those types of things, would not have accepted this. In fact, they did not accept it, but it just didn't matter. Even today, if you think about it, we have the MSM media complex, which is constantly bashing anything you could think of related to Trump and Musk, and nevertheless, things are going in the right direction for all these types of players. So I thought it's interesting to think about the second order effect of Gen AI, because Gen AI is certainly the biggest thing that has happened in the last couple of years on the technology front. And what's interesting about Gen AI is a few things. One is that actually it looks like AI is going in the creative route. So instead of replacing the truck driver or the kitchen busboy, it's actually replacing creative people, whether it's or knowledge work. So that's pretty interesting in its own right, if you think about it. But what does that actually mean for investing in business? And we would argue that this is opening the path towards robotics. In fact, Gen AI will replace the busboy in the restaurant. And here's why. One of the biggest problems of robotics is data scarcity. Like, you don't have the data that is necessary to train robots because you don't have the combination of situations and actions which you need to train something. Tesla has been able to train their FSD robot, their full self-driving car, which is basically a robot on wheels, because they had access to human driving data, which is not just the driving itself, but also the actuators associated to the particular scenes. So when you're in front of a stop sign, the car doesn't just recognize the stop sign, but it also associates the stop sign with actuators, or if you want to use a bit more technical term, a distribution of possible actuator positions. And then it picks the right one, and if FSD is trained over enough iterations, then hopefully it will be able to drive itself. This is how FSD is trained. Now, robotics, or humanoid robots, excuse me, they cannot be trained like that because we don't have access to all that data. So then one alternative is, what people have been doing in the industry is to collect the data. So we have teleoperation, and we have we have those sort of things, which are all fine. RT1, RT2, RTX. We've spoken about this on this podcast several times, and shout out to all these teams that did all that work. But I think the biggest sort of step change in the industry is the emergence of large language models and multimodal models, vision language action models in particular, which are now being deployed at scale by companies like Physical Intelligence and many other robotics people. And what that allows is for simulation. This is the key. For example, DreamGen, which is an engine by NVIDIA, offered by NVIDIA, which takes images in 2D and turns them into 3D scenes. So, for example, people talk a lot about the first sort of AI-generated movie, which might or might not be coming anytime soon. And that's exciting, of course, and we'll all get excited about this. And and it's going to be like Avatar and all that stuff. But that's not where we see the second order effect. The big second order effect, in our opinion, is going to be that Gen AI, the way it's proliferating right now, is going to allow for massive reinforcement learning driven robotics, because you can have very little bootstrapped data from teleoperation or robot data or something in between, and then bootstrap from there through generated videos or scene actuator combinations. So you can have a sequence of, you can basically build a database or a knowledge base of scenes and actuators that belong to those scenes through reinforcement learning. So the way I envision this is that you have an ability to creatively create realistic scenes, because they're embedded in reality. They are prompted with real scenes, with ground truth, and trained and through, let's say, vision language models. So they have a ground truth, they have a reality representation. What they don't have is the scenarios that are necessary to train a robot. So for example, if you want a robot to pick up a cloth of cotton, the robot just doesn't know how cotton behaves. But if you can generate many iterations of how cotton behaves and how actually touching cotton behaves, and then train it in reinforcement learning based on real images of how cotton behaves, then you could potentially very quickly, when I say quickly, I'm assuming Jensen's law here, which is a sort of 1,000x improvement of token per dollar, or token per second, or token per watt, or whatever you want to use. So those sort of metrics will dramatically improve the ability to train. And let's not forget reinforcement learning, which is the new hot programming language of robotics, as did in our ICRA podcast, for example. So reinforcement learning is really basically a method to generate synthetic data. So reinforcement learning is sort of a native data generation method, because you learn from the mistakes. So what you need is, you need a lot of try and error, and all the mistakes that you make are actually part of the learning process. So therefore, reinforcement learning, coupled with Jensen's law, actually is going to allow massive improvements in robotics. And that's why I think also Elon Musk is expecting an Optimus to be sent up to Mars within the next 18 months, because he's betting on those types of massive advancements in AI and reinforcement learning in particular for robotics. So to summarize, this is a pretty short clip, but I think we just want to put this out because it's important to state things sometimes, even though they might seem obvious, and maybe it's not that key. It's not like we invest by thinking of second order effects or anything like that, but understanding where a certain technology stands in the arc of development, and also understanding these second order effects and how they could impact the future trajectory of technological development, I think are very helpful. And I think it also explains second and third order effects are typically not something humans look at, particularly not human investors. When you talk to, let's say, pension fund managers and people like that, they will not invest in second or third order effects. Nobody invested in Bitcoin or Uber because it was a second order effect of social media. They invested in it because they thought, oh, well, they can, I don't know, solve a certain specific problem, which is fine, by the way. But I think understanding the second order effect gives you a better view or a better line of sight also where this technology is going and why it's being enabled in the first place, or to answer the big question, why now? Thank you.